From ContainerDays Hamburg, this video is proudly presented by Dax IT.
My name is Jan. I'm a software engineer at Kedify, and with me on stage is Christian. He works as a principal solutions architect at AWS. Now, with autoscaling on Kubernetes, you have two problems to worry about. Like problem number one, how do you autoscale your workloads? Like how do you scale up your deployment, jobs, stateful sets? And problem number two is how do you autoscale your infrastructure? So your cluster, your nodes. Now, luckily for both of those problems, there are already existing solutions. And today we're going to talk about two of those, Karpenter and KEDA. And before we go any further, let's do a quick exercise. Like you're going to raise your hand, kind of like this, if you know what a Karpenter is. All right, that's a lot of people. Now, keep it up, and raise your other hand if you also know what KEDA is. And if you don't know Karpenter, you'll just have one hand up. All right, cool, nice. Yeah, so as kind of demoed here, like you can use one or the other. They are not dependent on each other, but they really, really work well and complement each other if they are used together. Now, Christian, you work at AWS. You have a lot of customers. You see a lot of environments. What's the adoption like at AWS? I mean, Karpenter, that's AWS technology, so I assume everybody's using that?
Well, not really. I mean, it's not AWS proprietary. Now it's open source. We've started it, but it's now part of CNCF. But I see a lot of customers using Karpenter, but not many customers doing the proper way on the auto-scaling for the workloads. I still see people using HBA.
That sounds like trouble.
And scaling only on CPU, which is basically a saturation metric. But not many people is doing actually with KEDA and event-driven auto-scaling.
Yeah, you know, that's fine. I can totally relate. Because like not too long ago, I also knew nothing about autoscaling. I knew nothing about KEDA. And if you happen to have friends who don't do autoscaling, they're running Kubernetes clusters, but they don't do autoscaling, you should just tell them, like, man, use KEDA. And they're probably going to tell you, like, what's KEDA? And you're going to tell them, well, KEDA, that's a Kubernetes event-driven autoscaling. And then they're going to say, what? And you're going to say, like, hey, this is this open source project. It's maintained by like a great group of engineers. Also this guy, I don't know how I got there. And it has a great community, like really nice people. They're contributing their work. They're autoscaling their clusters based on some arbitrary measurable thing in the world. And they are contributing their code to KEDA. They understand the technology, and you can really scale based on anything. Like you can have a third-party software, you can have a SaaS somewhere, like Datadog, for example, or even like a metrics from your cloud provider. And yeah, it tries to make it really, really simple. And then you probably have their attention, and they're like listening, they're curious, they're wondering what they can use it to scale with, and how does it work? And luckily, we have that covered. Like you can show them this slide, and you can tell them, like under the hood, there's this thing called HPA, horizontal pod autoscaler. And what it does, it's kind of in the name, right? It horizontally scales pods automatically. So you'll have some number of pods, and your metric is telling you, hey, scale up or scale down, whichever is the direction. Now, where does KEDA come in the picture? Because right now, you can do the horizontal autoscaling with just vanilla Kubernetes. And usually, you would configure like a CPU or a memory trigger, which makes it scaling reactively. Right? Your workloads, your backends, they're already super busy, and then they are starting to scale up. That may lead to issues. So you may want to be a little bit more proactive. You want to scale before your workloads get really busy. So with KEDA, it makes it a lot easier. Like technically, you can do it without KEDA, but man, just use KEDA. It's easy. Here, we have used an external metric source. On the image, many of you probably recognize this. That's a Prometheus. And really, you can measure anything that's measurable. The benefit here is that you're not, again, waiting for a CPU and memory to get busy, but you're looking, for example, at your load balancer, and you're checking the number of requests per second. And whenever a request per second reach a certain value, you say, oh, I got to get my backends scaled up because they're going to get really busy. The second thing KEDA does is it can also scale to 0. Now, with vanilla HBA, if you scale to 0, HBA needs metrics to scale up. And if there's no pod running, there's nothing to measure. There's no metrics, there's no CPU and memory utilization. So it has no way of knowing how to scale from 0 to 1. With KEDA, because you're measuring something else, something external, an external factor, you can activate it. You can activate your pod. You can scale it from 0, and that's like the ultimate saving. So this is the whole thing. This is KEDA. Now, how do you configure it? How do you plug it into your application? You create a resource. It's called scaled object, and there's a ton of configuration, but this is the core. This is the essence of how would you configure scaled object. Even I don't know all of the options that you can use on the scaled object. But here, the basics, you configure boundaries. You set it from 0 all the way to 5, like it can scale. You don't have to run anything, and also you can scale all the way to 5. Then you tell it what to scale. So in this case, we're going to be scaling a deployment. It's called HTTP server. And then you configure a trigger. That's what the community is maintaining, and they're sending great patches and PRs. In this case, it's a HTTP-based trigger. It will calculate the number of requests per second, and our target is 10. So whenever you get 10 requests per second, you get 1 replica. When you have 0 requests per second, you have 0 replicas. When 20, 2 replicas. 50 requests per second, 5 replicas. Now a trick question, Christian, do you know? If you have 60 requests per second, how many replicas are you going to have? 6. Close. Anybody else thinks differently? It's actually going to be 5 because we configured the boundaries. Like, you don't have to know, right? It's fine. It's fine. Like, nobody knows everything. We're people. We're human. And right now, I'll need your help because I don't know how to use a computer. I'll do a little demo.
Would you know how to program it?
I pretend very well. I pretend very well. All right. I prepared a little demo. Now, here on the top of the screen, there's a simple kubectl command. It's showing the deployment. It's the same deployment that I kind of talked about before. It's a HTTP server that's handling requests. Right now, it's scaled to 0, so we are saving all the money. The second command is we at Kedify, we have built a little CLI tool that can help you get insights from your applications and the scaling metrics. So you can get it differently. You don't have to use the CLI, but it makes it easier. Right now, it's showing there's exactly 0 requests per second going through the application. And on the bottom, there's a simple graph that shows the replicas over time, like how are we going to scale up and scale down. When I start a demo, it's first going to send a single request. We're going to see. We're going to wait for the application to scale to 1. We're going to get the response. And then we're going to run a couple of benchmarks. We're going to ramp it up and send more than just a single request. So hopefully it works. Right now, we're going through a cold start, and it does seem to be working. We're sending the first request. The application has scaled up to 1 and has handled the request. It responded. We got OK 200. So right now, we're going to send more than just a single request. We're doing 15 requests per second. And we can see that the value in the middle is growing. And with the value growing, when you're going to hit roughly 15, it's also going to scale up. It's no longer running a single replica. It's running 2 replicas. The benchmark finished. We have got all OK 200s. It took about 16 seconds. And right now, we're going to run a stronger benchmark. We're going to run 50 requests per second, and we're going to really test it out. And as you can see, the metric is growing, and it's scaling in real time. As soon as you're getting the metrics, and with the HTTP scaler, you're getting the metrics immediately, you can see that the application is scaling at the same time. Again, we got all OK 200s. We finished the benchmark. The metrics going down because there are no more metrics flowing to our application. And the application is scaling down, and it will scale all the way down to 0 for the ultimate savings. So that's all on autoscaling of the workloads. And I'll hand over back to Christian.
Yeah, all right. So at some point, the cluster is going to be constrained when you have when you've been scaling out and adding more replicas to the cluster. This is basically where Karpenter comes into the picture. If you already know about Karpenter, you know that it's a cluster autoscaler project, similar to what cluster autoscaler does. But in this case, the devil is in the details, basically. Karpenter works on an application-first approach where you actually set the constraints that you want for your workload, what the compute specs you need for a workload, and Karpenter will use those constraints and will anticipate to what the kubescaler is going to do. Contrary to what cluster autoscaler does, Karpenter does not clone internally the code of kubescaler. It basically uses heuristics and try to make the best effort and try to make it as efficient as possible. And one of the main mantras of Karpenter is launching the capacity that you need at the lowest price possible. Of course, I have several or a few complaints from customers that that mantra has not been followed. We can dig about it. We can actually deep dive on what the constraints are, how is it working. Because once you have everything working in a production, things tend to get complicated. Believe me on that. The other feature about Karpenter is that it helps you to diversify. We're gonna deep dive a little bit into that later, and you're gonna see why that matters. But basically, to keep it short, Karpenter is gonna help you to increase the diversification of the instance types. You simplify the configuration. You don't have to create managed node groups in advance in order for things like diversify with spot instances, for example. Karpenter is taking care of the nodes that is launching, is not using autoscaling groups if we're under AWS jargon. And that's basically it. It's basically not just going to scale out, but it's going to continuously monitor and make sure that you have the best of the best running all the time if you allow it, right? We're going to see what that means in a moment. So effectively, what it does, as I was saying before, it works in tandem with a kubescaler. It anticipates to what it's going to do. Just to make things clear, if you already know about Karpenter and if you are new to Karpenter, Karpenter is not in charge of scheduling the pods, all right? It's still responsibility of the kubescaler. Karpenter just anticipates to that, but Karpenter has nothing to do with scheduling the pod, all right? And that's what I wanted to show you here. So if you have some pending pods, maybe it's clear if I show you with this one. If you have some pending pods, as Jan was saying, we keep adding more pods into the cluster. And at some point, the cluster is going to be constrained on the capacity that you have. So Karpenter is going to say, like, hey, from the pods that you have here in yellow, 2 actually fit already into the cluster. But for the rest of it, let me create a node where the pods fit as efficient as possible, given the constraints that I have for Karpenter, my workloads as well. It's going to try to make the best decision possible. How does it do that? Well, basically, Karpenter used the beam packing algorithm, and it basically, when you have the pending pods or the pods that are on schedule due to capacity constraints, it orders them descendingly on CPU, memory, and now even GPUs as well, and tries to do the beam packing with those pods. At some point, you're going to end up with either one big node, putting all the pods into that node, or depending on the constraints that you might have, it might end up having several nodes as well. It basically uses the well-known labels that we already know. Karpenter also adds a few other labels that it uses for scheduling purposes. Now, Karpenter does a good job on scaling out, but it's also doing a good job on scaling in. Similar to what KEDA is doing with giving you the ability to scaling down to 0, which is something that you don't have with HPA, Karpenter basically helps you on consolidate nodes and try to have the less nodes as possible. What it works is basically every time that something happens into the cluster, or every time that a trigger of 10 or 15 seconds, it is right now, if I recall well, it's going to try to run simulations. It's going to try to say, like, hey, if I evict this pod from this node, what could happen? Can I launch a smaller node, or can I basically try to play around Tetris and remove a node and try to force the queue scheduler to schedule again and try to make use of the capacity that I already have? Because one thing that Kubernetes scheduler by default does not do at the moment is that once you schedule the pods, they're going to stay there. But there's no something continuously monitoring that the pods are still in a good position or in the best node possible, because you know that some pods have been removed already into the cluster. So let's say that we remove some pods here. Karpenter is going to run the simulation, and it's going to say, like, hey, I'm wasting the capacity here. So I'm going to launch a smaller node, and I'm going to make sure that once the node is ready, I'm going to evict the pods. So that is when the kubescaler comes into action, and it's going to deploy the pods, right? So once the node is empty, it's going to remove it. If I continue scaling down and I remove some replicas, in this case, there is no smaller node that I could use. So what it's going to do, you can see very graphically that one pod could fit into another node. And that's basically what Karpenter is going to do. It's going to evict the pod, it's going to taint the node, and that is going to force the queue scheduler to deploy the pod into the corresponding node, making this node empty and basically removing that. Now, enough talking. Let me show you the demo here. If my internet connection works really well, looks like it's working, I'm going to try to do it live. Else, I have the fallback mechanism that I recorded the session as well. So on the top, you can basically see I filtered the nodes that are going to be launched by Karpenter so that you can see how much is basically spending. You can see basically here that for Karpenter, I'm not spending anything else. This is a tool that is going to give you the nodes of the cluster and how much capacity has been reserved by the pods, and it's going to give you an estimation of the cost as well. Here, I'm going to basically have the Karpenter logs so that you can see that it's actually running live, and we can actually inspect a few things that I've been talking about before. Then here, I have scripted the demo, and the first thing that I need to do is to create a node class and a node pool. And while I'm doing that, let me continue, and I'm going to deploy my workload, and I'm going to make sure that I can scale out the workload. And then I'm going to show you, while that happens, while Karpenter provision the node, I'm going to show you basically what the node pool and the EC2 node class look like, so you can see what it's going to do. So basically, I'm going to add replicas here. You can see here that I'm going to have 10 pending pods. Karpenter is going to react onto this. It's going to say, look at it. The node came right away. So it says like found provisionable pods. Basically, it says like now I'm going to provision 5 pods extra because of the kubelet, kubeproxy, and a few diamond sets as well. And what it's going to do is basically give me the instance types that are good candidates for this, plus any other 55 instance types. So if I'm flexible enough, Karpenter is going to take a bunch of list of instance types that are good candidates to host my node, and it's going to send these to the EC2 API fleet, and is basically EC2 in charge of giving the capacity that I want. If it's on demand from that list, it's going to pick the cheapest one, and that's it. So you can see here that the node is being ready, is being created, and while it's ready, it's going to take a few seconds here. Now it's ready, and the pods are going to be scheduled in a moment. But while I do that, let me show you what I did, what the node pool looked like. So you can see here that it's basically a CRD, and something like very similar to already, if you're already with other CRDs, you basically define the requirements here. The capacity type that I want is going to be on demand, and I'm filtering here the sizes of the instances that I do not want. Everything else, I'll let you to choose the best option available. Don't worry about if you are not limiting with really big instances. If Karpenter thinks that that's going to make sense, it's going to launch it. If not, it's not going to launch it. Okay? The architecture, I'm including x86, and I'm going to tell you why in a moment. I'm also limiting the CPU here and the memory, and I'm adding some disruption policies for consolidation that I was saying before. Budgets here as well. I'm going to talk about that later in a moment. So you can see here that the pods were scheduled, and look at the price of the monthly cost of the monthly cluster for these Karpenter nodes. I'm gonna ask for Jan to remember this number because we're gonna decrease it. We're gonna keep it down.
Yeah. Now, I mean, $500 for a demo. That's a lot of money.
Well, that's monthly. Okay. So the first step that I'm gonna do is on to optimization and efficiency. I'm gonna move to Graviton instances. So that's basically the custom silicon chip that we created at AWS that it's basically running on the ARM architecture. And if we go to the pool here, let's see, let's just make sure that, yeah, I apply that. And basically, I just changed the architecture. I did anything else, nothing on the application. I just have Karpenter installed already. And as soon as I do that, notice this.
Whoa. It costs $900 a month now.
Yeah, hold on.
Great optimization.
No, hold on. Let's break down what's happening here. So remember what I said before that Karpenter is running simulations, right? So it noticed that you added a new flavor. Now you added ARM-based instances. So because you changed something, it's gonna run simulations. It's gonna say, hey, now I have another set of instance types. C6G 4x large, it's at least 20% cheaper than x86. So I'm gonna go with that. Basically, it find out that there's an opportunity for improve the cost here, and it's very deterministic, even though it looks like there's nothing, there's no black magic under it, there's no AI under it. It's very deterministic, it's very consistent, and it's gonna do things over and over again. So effectively, what it does, what I told you before during the slides, right? So it's basically cordon and deleting the node, and it basically evicted the nodes, and the pods were basically moved to this cluster. By who? By the kubescaler, right? So now, Jan, see this number again.
I like that. I like that so much that I'm gonna put my money on the table now.
Okay.
I'm gonna say that how much we save, I'm gonna put that into my beer budget.
Okay.
And after the last 2 nights, it's actually pretty empty. It's like 7 cents remaining. And I kind of need the money because otherwise I'm not gonna be drinking beer and not gonna be a lot of fun at the parties. So please, save a lot of money.
And you're in Germany as well, so that's a good call. All right, so now you can see here that basically by just changing something in the node pool, I was able to do that. So now let's do something else. Right now, if you can see here in the deployment, well, I did the change already. I'm gonna apply it anyway. At some point, I was running load test into my application. I'm simulating this because it's gonna be quicker doing this way. You can see here that the reservation decreased because I'm requesting now, instead of only 1 CPU, I'm requesting 2 55 milli CPUs. So the request decreased. Karpenter again ran a simulation disrupting node, and it found that a 4x large, it's too big for this. It's too expensive. So you're gonna see here that Karpenter is already doing the work, launching a new instance type, C6G, same type, 4x large, with a different price. Okay, so you can see here how we are basically just iterating into this, how we are adding more stuff into the ecosystem, into the platform, into the cluster that we already configure. We already have Karpenter installed. We are just making sure that it's running as efficiently as possible. You can see here that the pods were moved, and now basically it's gonna repeat it again. It's gonna remove the node. Once it's removed, you're gonna hear that the price is gonna change. Now, what I'm gonna do next, because it's gonna get a little bit tricky, and I wanna finish on time as well. The next step on optimization is gonna be around spot instances. Spot basically are the spare capacity that we have at AWS. And before I continue that, just make sure that we have the new number.
That's more like it. I think I can party not only tonight, but also tomorrow.
Okay, nice. Be careful there. All right, now I'm gonna make the move to spot instances. Similar to what I did with Graviton, I'm gonna apply the change into it, the cluster. And you can see here that the node pool now has on-demand spot Graviton, basically, if you've been hearing me a while ago before, it's the best of the best. Running Karpenter, Graviton, and Spot is going to be the best formula where you can get the lowest price as possible. You can see here that, again, consolation kicked in. Why? Because Spot is going to be up to 90% of the on-demand price. And you can see here, it's an average. It's basically a simulation. It's not going to be... all of this is going to be an estimation. Of course, there are other things that come into account at the end of the month on how much you're going to be charged. So it's going to launch M6C X Large. While all of this mechanism finishes, let me tell you what happened. Because it's running Spot and find out that Spot instances were cheaper on that. From that list of instance types, that is becoming even more crucial. Because from that list of capacity of instance types, that is going to be sent to the EC2 API fleet, and it's going to be using a different strategy. It's not going to be using now the lowest price, but EC2 API fleet has an algorithm that is called price capacity optimize, and it's going to look for the instance types that have more spare capacity, and from that, it's going to pick the cheapest one, right? So it's going to basically do a balance of that, considering capacity as well. Why? Because the idea is to reduce the likelihood of getting that interruption. If you didn't know about what Spot instances are, the only but about Spot instances is that they are interruptible. But if we're honest, containers are interruptible by nature, but I know that some applications are not like that. We can work around, we can actually make our application more fault tolerant. And I'm going to be the first one to tell you that do not use Spot instances if your workload is not fault tolerant or stateless. All right? Even though if you see this new price here.
Like this.
So by just using Karpenter, doing right sizing, using Graviton, using Spot instances, we basically decrease almost 10 times the monthly price of the cluster. Now I'm gonna basically just leave it here. Gonna be run it here, and I'm gonna give you a few resources as well for you if you want to learn more. I have created a repo called Karpenter Blueprints that are gonna give you a few patterns and a few best practices in a very simple way that you could use to basically do things like what I'm doing right now. I'm gonna basically move to making the split to having 80% or 20% of on-demand and the rest on Spot instances. You can basically do that, and during that repository, you can explore that. Unfortunately, I don't have time to show you that, but I just want to close out with that. And of course, we're going to be here if you have any questions. If you would like to dive deeper into this, I happen to finish a book that is going to be released very soon, where I go into these two topics very deep, so you can get the most of it. And it's going to be very hands-on. A lot of the labs that I've been working with, a lot of customers, are going to be included in this book, so make sure that you check that out. So that's it. Thank you very much.
When KEDA scales to 0, how is the first request handled? Does it risk timing out if the app has a cold start?
Yeah, so I guess that's a question for me. Now, KEDA itself, it doesn't exactly know. But there's something called an HTTP add-on. There's also a couple of commercial scalers, like one developed by us, by Kedify, the HTTP scaler. And that is in the business of caching the request. And as soon as it caches the request, it sends a signal to KEDA on a gRPC endpoint. And that endpoint is push-based, so it gets it immediately as soon as the request lands on the HTTP scaler. That's when KEDA starts scaling up. The cold starts, they're configurable, so they depend on your workload, on your type of application. If it has a long bootstrap periods, you may need to cache for a little bit longer. If it's fast, then you can cache for not a lot of time. And that's how it just handles the situation.
Thanks. The next question is around, does scaling to 0 with KEDA come with failing requests because the first application port has to start? I think it's the same question, maybe?
I agree. I think that's the same question.
Okay, let's hope over, because I see we have 25 questions now. Does scaling? No, I'm confused.
Does
It's the
scaling
same
to zero with
question?
KEDA? Yeah, I think a lot of people are interested in this particular topic. You can find me on the hall. I can chat. I can elaborate.
Is Karpenter a complete replacement for the Kubernetes cluster autoscaler? If not, how do the features compare?
No, it's not a complete. I think that I have other customers that are happy with cluster autoscaler because basically their capacity is very static, very it doesn't change that much, and they are happy with how efficient that is. So it depends on the complexity and how big your cluster is. To be honest, if your cluster is small, maybe you don't need to go over and complicate things, and maybe you can even just go with Karpenter, or in EKS we have a new feature that is called EKS Auto Mode that is going to be simpler.
Okay, thanks. For which cloud providers is Karpenter available, especially in Europe? Edson, Alice Web, OVH?
Okay, so basically right now the only one that as far as I know and as far as the community knows, is the one in AWS and in Azure. There's one for Google Cloud, but it's not Google Cloud developing. It's basically a partner that is working on it, but I think it's in alpha version. And about 1 month ago for Azure, that went live. By the way, in the community calls for Karpenter, there's people not only from AWS, but from other companies joining as well, and especially from Azure as well.
Thank you. The next one is probably a critical question. Are there a lot of open issues in the Karpenter issue tracker? Do you really think that it's ready for production?
So it's been ready for production since 2021, and we have thousands of customers using Karpenter. The number of issues that you see there, it does not correlate with how mature the product is. It's actually the contrary. It's actually saying that it's being quite adopted. And of course, as we are now using more the project, we've been finding edge cases, but we have several case studies. I personally have been working with customers that have been decreased their easy to build to 70, 80% on production with Karpenter, Graviton, and Spot. So yeah, it's production ready, and we have a lot of customers using that in production.
Thank you. The next is around KEDA again. How well does KEDA play with rollouts like multi-stage canary rollouts and Argo rollouts? We had issues preventing HPA and Argo rollouts fighting each other.
That's a great question. And the truth is, I don't know. Christian, do you know?
No, I think that maybe you will need to use one or the other, or basically disable or pause. With KEDA, you can pause the scaling. When you are going to be doing a rollout, you can basically add into the pipeline or basically a rule, custom rule, to pause the scaling object so that it doesn't do anything. While when that finishes, basically it can continue. But yeah, you need to be careful about having two projects fighting each other when scaling out.
But my point was, like, we're not sure. Like, we're trying to make a guess. And I mean, he's a principal solutions architect at AWS. So that's a proof that you can get very far in life not knowing this.
Yeah, not knowing is the best answer. Does Karpenter also make sense on premises or bare metal clusters for rebalancing?
It does if only we had a provider for bare metal, which that's not the case right now.
Okay, speedrun. Does Karpenter work with cluster API or AWS only? Probably we answered that.
Yeah.
When I tried making Karpenter run on our self-hosted Kubernetes, it was causing lots of issues. Will the support for self-hosted Kubernetes clusters improve?
Maybe if you can check out the blueprints that we have released on Terraform, maybe that could help you. Happy to give you a hand, or if you have any follow-up question, I can help you on that. But we have blueprints that are working with either self-managed as well.
Perfect, thank you. Do you have examples of complex Karpenter consolidation policies to avoid aggressive downscaling? Let's say I want to downscale one node every 10 minutes.
So yeah, that's something, if you remember on the node pool configuration, that at the end has budgets. Karpenter has a configuration similar to pod disruption budgets, but it's called node disruption budgets, where basically you can control how aggressive you want the nodes to be replaced. So you could say, you could configure either schedules, you could configure these disruptions by actions. So maybe you would like to consolidate aggressively or not that aggressively, or you would like to drift the nodes every week or so, or during working hours you want to actually block any disruption, any voluntary disruption into the cluster. So yeah, that might be something to explore in more detail.
Thank you. We have so many questions. I want to give the chance to at least answer some of them. Given I cannot use spot instances, how am I supposed to make reservations, reserved instances, if I do not know which node types I get?
So that's a great question. In the Karpenter Blueprints repo that I mentioned, there's an example of how you can take advantage of this approach or the reserve capacity that you want. Right now, it's a little bit hacky. Basically, if you already purchased saving plans, typically you will know how much capacity you bought and the characteristics of that capacity that you bought, even though you don't know about the instance types you might have purchased for different families. It depends on how you purchase the saving plans, but you can configure that as well, and you can limit that. And with node pools in Karpenter, you can basically have two node pools, one dedicated for reserve capacity. Once you reach out the capacity of that node pool, it can fall back to the other. But again, maybe that's a pattern that it's easier to understand with a demo or looking at the blueprint as well. Happy to have a follow-up on that as well.
Thank you. Next one is around KEDA again. Does the KEDA HTTP add-on also work with ALB ingress and can scale to 0 and scale up once the requests are coming without producing 503 errors?
Yeah, it's another instance of kind of the same question, scale to 0 with KEDA and HTTP add-on. So yes, it kind of depends on your application and the bootstrap time. Like the default, same default in the HTTP add-on is 30 seconds. That's how long it's by default going to wait for our application to come alive and reply. I mean, 30 seconds is already a lot, right, for customers. Like if they open a page and they're waiting for 30 seconds for something to load, might be a little upset. So it's how you kind of structure your application and how you design that. There's also a way to do something we call the shrink to 0. That means when it's inactive, when there are no requests going, you don't scale to 0. You just make the limits and requests very, very small. With the new work in the recent Kubernetes, you can do that even in place. You can resize the pods in place, and it's just waiting idle. It's probably going to be super slow responding, but as soon as KEDA sees that there is a request, you can blow it up. You can just say, oh, okay, now I'm going to put the real limits and the requests on that application again in place without restarting the pod. And at that point, that's kind of a hack to limit the cold start situation. But yeah, by default, there shouldn't be 503s.
Thank you. I think the next question is related, like a relevant question for many. When will you finally make a normal HTTP trigger for KEDA?
There's one, the commercial one. We are developing it at Kedify. So yeah, you can check us out. You can talk to us, and we're happy to demo that.
Perfect. Next question would be, what happens when your pod disruption allows 20% pods to be down, but a big spot termination happens taking down 30% of your capacity? Does it force terminate?
Yes. There's nothing that could block a spot interruption. You have 2 minutes, and even though if you have protection termination on an autoscaling group, even if you have a pod disruption budget or a node disruption budget blocking that, you have 2 minutes and that's it. That's basically how spot instances work. If you have something that critical, you need to find a balance between reliability, cost, and performance. think about it like a triangle that. So you might not have it all. So you need to think twice about how much restrictive you want to have that PDB or how flexible you want it in regards to the flexibility as well that you give to the instance types that you have in the node pool. You can actually test that in AWS. You can simulate a spot interruption and either interrupt like that. Same data scenario you can see how impactful that will be for your cluster and decide if it's worth it or not. And yeah, that's basically it. But in essence, with spot instances, the key here is to diversify as much as possible to actually reduce that.
Thank you. I think we have a lot of questions. I would invite you to come after the talk to our amazing speakers. Thanks again.
Sure. All right. See you around.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.